Friday was a snow day, and some of you did show up, and I did cover some material. In particular, I did some stuff with audio, the audio sources and the audio listeners, and audio clips and reverb zones and some other stuff. So if you weren't here on Friday, which is fine because Friday was a snow day, I highly recommend watching the YouTube or Kaltura video for last Friday, which includes a bunch of stuff about audio. I will pick up with all of the other stuff that I did and kind of repeat it. So let me get started with a share screen here. And clean this up. So what I had started to talk about Friday was the player state machine. And we're going to build a very simple game here with a player and objects that can damage the player and objects that can award the player points when the player contacts them. And we're going to keep score. And based on that score, we're either going to win or lose. And we're going to do this basically with 3 scripts. And these scripts are going to communicate with each other. And this is a very important aspect of Unity, is the communication among scripts on different objects. All of our objects have these components. We can write components. That's what these different classes are, the player status, the damage, and the pickup. And we can put them on different objects in the scene and in the game, and they can interact with each other. So starting off with this player status script, which we're going to put on our player object, we're going to have public, health, and point variables. We're also going to create some functions that add or subtract health, and we're also going to have functions for the win or lose conditions. And ultimately, we'll have a UI that displays the status on the screen. So very simply, if we create a new script, it'll have these usings at the top of it. These are different libraries that our scripts need to have access to. We have the class name, player status, and we have 2 public variables, public health and public points, and we have default values for them, 100 and 0. And any script that we create will also come with a start and an update function, which at this point have nothing in them. So if we just save this onto our character, and we look at our character here, the FPS controller, here's that player status script. Here's the exposed variable for the health. Here's the exposed variable for the points. I often include a Boolean debug that I can then put in front of various print statements or debug statements that will give me information in the console about what the program is doing. And I can turn them off very easily by clicking that debug. Those debug values, if I say change my points to 10,000 here, and obviously I can then play the game for a long time without running out of health. But the reason for these default values here is that I can then go back here and with this little button here, do the reset, and it will go back to the default values that are defined in the script. I want to turn debugging on so that we can see things happen when we play. So I'm going to create a damage object, a cube that I've stretched out into a wall. I've got a collider on it, And here's an important part. That collider has to have its is trigger set. So here's my firewall. It's got some pretty texture on it. It has a box collider, and the is trigger is set on that box collider. Now, when is trigger is set, the collider no longer is something that we bump into. We can pass through this collider. But when we do encounter the collider, it's going to send messages that various scripts can pick up and do things with. And one of the things we're going to do is apply damage. So in the player status script, we're going to have a public function, apply damage, that has an argument, the total damage, and it's just going to decrement the health by whatever the total damage is, and it's going to test that health to see if it's gone below a certain level, in which case it's going to call a kill function. And the kill function at this point is very, very simple. All it's going to do is do a debug log message, you are dead, that's going to display in the console, over here in the console. So back on our firewall, we're going to create a script damage. And the update and start functions aren't going to be used. You can actually delete them if you want to, or we can just leave them empty. What we want to have here is the function that's going to catch that message that the is trigger collider is going to send when something enters its collider. And this is the on trigger enter function. There's also an on trigger exit and an on trigger stay. The exit when we leave the collider, the stay every frame while we're inside it. Now, these on trigger functions have as an argument the collider that has tripped that trigger. So that's going to be my player, presumably, is going to have walked through the firewall. And so here I'm going to get access to the player status script. And I do this by defining a variable of type player status. That's the script that's on my player. Whoops. Its name is also player status, but notice the difference in case. It's capital player status, the type, and it's lowercase player status, the variable. And this is assigned to the collider that has entered the trigger. We use the get component to access the player status script that's on our player. And then with that variable named player status, I invoke the function in the player status script, apply damage, and I apply some amount of damage, which presumably I would have in a public variable up somewhere at the top. So the on trigger enter has as argument the COL, the collider that enters the trigger. Player status with a lowercase p is the variable. Player status with the capital P is a type and matches the name of the script in the function player status here, which is the function that we're accessing. And invoking the variable player status with the method apply damage, it's going to communicate to the player status script that it has to decrement its health by a certain amount. So here's the complete script. We have a public variable, and I remind you that these classes, the name of the script has to match the class. So the name of the script must be damage, exact same capitalization exact same spelling. So we put that on our firewall. Here's my firewall. And it has a damage script on it. I'm going to do 25 units of damage every time I go through it. And if I play here, and let me watch the console. If I play here and go over and pass through the wall, because I had that debug on my player status, it's printing that the health is now 75, the health is now 50, the health is now 25, the health is now 0, and it's printed the message, "You are dead." Now, let me quickly look at the player status script here, because there's something that's not in my takes a while for visual to open. Takes forever. So I have this little public Boolean debug that by default is false, but I've clicked it and turned it to true in the inspector. And here I'm testing if debug is true, then I do a log warning. The log warnings make these little yellow symbols. The kill just does a regular debug log, and it makes the little white symbols. And over here, I can turn on and off the different types of debug statements that I have. These are errors, which I don't have any of, thankfully, at this point. Later, we'll generate some. But you can turn on and off these different types of debug messages that you can send to yourself in the console and take care of them. So we've got a damage object. Now, the next one we want to do is the pickups, the power-ups, the things that add points to our player. And so again, back in the player status script, I'm going to add 2 new functions. Again, a public function, add points, with an argument total points, and it's going to increment points by that amount, and it's going to test to see if points has exceeded some level, in which case I'm going to call the win function, and the win function is going to be a debug log, "You won." Now, over on the pickup objects, of which I have several here, I have a little pickup script, and it's almost identical to the damage script. It has the various usings that we have to have. Its name is pickup. We have a public variable for the number of points that we're going to award. It has an on trigger enter, and the pickup object's collider must be set to on is trigger, and it's going to access the player status script in the same way that the damage did by get component player status. It's going to call the add function, the add point function on the player status. And what's different here, it's going to destroy itself. Destroy game object destroys the game object that the script is attached to. You would not want to destroy collider, COL here, because that would destroy the player. So the point of this is that we want our pickups, unlike the firewall, which persists after we pass through it, we want our pickups to disappear so that we don't just collect the same pickup over and over again. So again here, if I watch the console, and I believe I still have the debug on the status, the player status. If I play now and I go over to these pickups and I go through one, I get the message that points are now 25, and notice it's gone. I pick up another one, I pick up another, and I pick up a fourth, and I've won. I'm not doing anything fancy here with the win or die condition, but we'll do something fancy with that later. So we can save and drag that into the pickup slot, put so many points in it, be sure that colliders trigger is set, and we can play and run into the box and it'll disappear. Or we can change the points back to 25, and now we have to hit 4 of these in order to win. Now there's one more that I want to do here, which is a bomb. And so this one's a little different than the damage wall, because this one's going to kind of behave like the pickups, in that when we touch it, it's going to damage us, but then it's going to disappear. And we can put it, later we'll put explosions on it and do all kinds of weird things. So here in the scene, I have a little bomb. And the bomb is this little sphere. And one trick, and it's got a rigid body, so it's going to fall and roll. And one little trick that I've done here is I've put 2 colliders on it. It has a sphere collider that is not set to is trigger. This is what it's going to roll around on the ground with. It's going to roll on the sphere collider. But I also have a box collider. You can kind of see its outline in the scene. And this one is set to is trigger. So it's not going to roll around on the ground as a box. It's going to roll around on the ground as a sphere. And the box is trigger is the thing that our script is going to catch. Now, there's one other thing that we have to be very careful of here, and that's that we have to recognize that this box collider is going to be constantly colliding with things. It's going to be touching the terrain as the smaller sphere collider rolls over the top of it. It might run into a tree. It might run into one of the pickup objects. And so instead of just getting the player status with a get component, I have to also test whether that get component was successful. And I do this by saying, if the player status, presumably returned by this get component player status, is not null, then I can call the function apply damage. If I didn't have this, this would throw a whole bunch of null reference errors every time the box collider here touched the terrain or a tree or anything that it encountered in the scene. And then, like the pickup, I'm going to destroy the object. I only destroy the object if it's touched an object that has a player status that is not null, and we've successfully applied damage points and then destroyed it. So the bomb is going to roll across the scene here, and I'm going to try and get over here and intercept it. And I think I did, because it's disappeared and my health is down by 25, and I can go over here and run through the damage wall a couple times and die. So that's the basis of our game. Now, later, I'm going to put a UI on this thing. I'm going to put a display that's going to display our health and points. And so in the player status, I'm going to make 2 more public functions that that do nothing but return the number of points we currently have and the amount of health we currently have. Get points and get health. And they're public, so they will be callable from other scripts. And all they do is return point and health value. So note the communication that's going on among the different objects in their scripts. The player has this player status script that keeps track of how many points we've got, what the health is, and it tests those values and invokes either the win or the die condition, and it calls the appropriate function that will tell the user what has happened. The pickup, damage, and bomb scripts, all with colliders that are set to be is trigger, also have scripts, pickup, damage, and bomb, that handle the messages from these colliders, calling the appropriate functions, add points or apply damage in the player status script. Lots of communication going on here. So I'm going to pause here. Later, we'll come back and do a HUD, heads up display, but I'll entertain any questions here at this point.
Can you have two triggers on one object
Yes.
at the same time?
Yep.
Okay, thanks.
Two colliders, each of which would be a trigger, yeah.
Okay.
You would, if you had a script that was, like these messages go out into the world, so it's not just the collider that has the trigger that gets the message. Other objects in the world will get the message too. It's kind of a broadcast that something has happened. But so if you had two triggers, you would get two sets of messages. But you could have different size triggers. You could have one that was up at the character's head and another that was at the character's hand. And you could then do damage to their head with one trigger and damage to their hand with another one. Okay?
Okay, thanks.
So no other questions. I'll go back to sharing screen here. Now, I'm not going to do anything with this one. There are two UI systems in Unity. One is called the immediate mode GUI, and it's a heads-up display, and it can put things on the screen. But the immediate mode UI is, and this is from the manual, is not generally intended to be used for in-game interfaces. For that, you should use Unity's main UI system, which offers a game object-based approach and has better tools and much nicer visual design. The immediate mode UI is all done via scripting. And I'm not going to do anything with this, but it's all done with the onGUI function where we get the player. Here's that get points function that I put in the player status. Here's the get health. We've got things called skins that kind of define what kind of fonts we're using and colors and other stuff. But here I'm putting up labels that have recs. And the only thing that I might show you in this script that's kind of interesting are these directives that are up here: add component menu, my script HUD, and execute in edit mode. And these are two that we might use later. And here is a scene that has the immediate mode HUD in it, which has the health and the health and points values. But if I look at that script for the HUD, I have these execute in edit mode. And if I find it here in the scene, and I change the position here, you can see that that moves around. That's executing in the editor. And this doesn't just apply to immediate mode stuff. Any of the things that we do in Unity can have an execute in edit mode, and we'll then be able to play with things in the inspector and have it appear immediately in the game view, and that can be useful. But I'm not going to do anything with the immediate UI because it's actually intended for other stuff. It's intended for use in the editor, and so I'm not going to use it. Instead, what I want to talk about is the new UI, and I'm having trouble breaking myself of calling it the new UI because it's no longer new, it's now the UI, and that the older legacy script-based UI is now called the immediate mode UI, GUI, and we primarily use it for custom editor scripts when we're writing editor scripts, which is something we may or may not get to. The editor scripts, we can have custom UIs when we modify our own inspector. Links here to the manual for the UI system and also to a tutorial for the UI, both of these on the Unity site. Now, the UI is much more powerful than the immediate mode. It's much easier to use as well. You don't have to do it in scripting. You do it all with predefined objects that Unity provides to us. But it's definitely an example of a TMO, too many options. So becoming easy with it takes some time and study. Let me close this scene here. Don't save. And open a new one. So there are a lot of UI tools. I'm going to deal with three primarily. I'm going to look at buttons, sliders, and text areas that we can display text in. That's my dog. So here's kind of a sampler of some of the elements, the UI elements that are available to us. Let me maximize. So we have buttons that we can press. You can do all kinds of fancy things with the outlines of the text. We have these scrollable windows that we can put instructions in. We have these little toggle things where we can click different items. We have pull down menus that have different options that we can select. All of these will convey information to scripts. We have sliders we can move around. We have scroll bars that we can move around, and we have boxes into which we can enter text that will then be captured by the scripts that are connected to our UI elements. But I'm going to mainly focus on buttons, sliders, and texts. Now, in order to have access to these objects, these classes, there's a text class, a slider class, and a button class, we have to include a new using in our scripts, using unityengine.ui. This we add to the default ones up at the beginning of any script, and we then have access to those different components in the script. It's kind of a library. Now, the basis of the UI is the canvas. You can create a canvas directly, Or if you haven't got a canvas in your scene and you create any UI element, it will automatically create a canvas, and whatever you have created, the button, for instance, will automatically be a child of the canvas. So back here, and I want to not maximize at this point. In this scene, I've got some stuff, but I don't have any UI elements. If I do a game object, and here I could directly make a canvas, but if I make a button, it automatically makes a canvas, and the button is automatically a child of the canvas. And it also adds this event system, and the event system is necessary for these things to work interactively. One pitfall that people sometimes fall into is they make a nice canvas, they prefab it, they put it back in their assets folder, they put it into a scene, and it doesn't work. And it doesn't work because they don't have an event system. So you have to have an event system for the UI elements to work. Now, the canvas has a number of options. First of all, let's look at what the canvas looks like in our scene. Here's my little cube down here and my little plane, and you can see the canvas is kind of huge. And the canvas has a rect transform. Rect transforms are kind of the UI equivalent of the transform that we have on game objects. The game object transform that says where it is, how it's oriented, and what its scale is. The rect transform is the equivalent thing for UI elements. Now, in this mode, which is called screen space, and screen space is where the UI elements are kind of on the screen of your camera. They're not out in the world, they're right on the screen. And when we have the overlay mode, the rect is grayed out. We don't have any control of it because the canvas completely fills the screen. And if you watch here, if I change the size of the screen, everything in the rect is updating because it automatically adjusts its position, width, and height to match the screen. And this will be true when we go and play as well. If I maximize, well, if I play and I have a different size screen, things are going to move around. Now, there is also a camera space, and there's also a world space. The camera space puts the object in, puts the UI element in front of the camera. Let me save that so that we can come back to it. So here now, my canvas is in, I'm sorry, camera space. It's in cameras, it's in screen space camera. And when we ask it to be in front of a camera, we also have to specify a camera that it's going to display on. And I believe by default it'll go to the main camera, but I'm going to put my first person camera in here so that it's displaying in front of my little first person. And if I look here now at my little first person, I can actually see there's the UI elements on a little plane out in front of my player's camera. And we can move that around. We can make it closer or further away from the player. And to emphasize that this is actually out in the world, if my little character walks into the cube, you can see the UI element penetrates it. The UI element is actually out there in the world in front of us. Now I've got another camera in the scene here. This is the 7B scene, where instead the canvas is on camera 2, that's the overhead camera. And so in this case, my little UI is in front of the overhead camera. And I can go down here and fiddle with these elements in the little button here. I can press the button and do all kinds of stuff. They're not connected to anything, so they don't do anything. So that's camera space. Now the last option is kind of the coolest one. It's world space. We can put the UI wherever we want to. We can put it in the world. And so here on this cube, I've got my canvas. And my canvas is specified to be in world space. There's an option for a camera. I should have a camera in here as well. I'll put the first person camera in. And notice now the rect is populated. And so we can now position this thing. And these positions, 0, 0, and minus 0.51, are relative to the object that it is the child of. It's the child of the cube. So putting it at minus 0.51, put the canvas just a little bit outside the cube. If I make this minus 0.49, it's now in the cube. 50 is okay, but it's a little bit weird, so it's better to put it a little bit outside. And you can adjust its width and height so that it fills the thing just properly. You can also scale it here, which is another way of adjusting its size. And so now in the world, I have this kind of console that I can move up to, and I can point at, and I can click and fiddle with the slider. And so I have this console device that I've found in the world. Here's the same setup, the exact same UI, except I have my little Ethan character in here so that he can come up and fiddle with the console. But that's pretty cool to be able to put these UIs on objects. One thing people do sometimes is they put a slider on their player that appears above their head, and that slider can then be the health points. So instead of having a UI element on the screen for your player, you can have a UI element over the player's head. This is a especially good trick to do with enemies that you're trying to kill, because you can have their health bar over their head as a UI element in the world. Now, everything I'm going to do is an overlay, but all of the different tricks apply to camera space or world space. And so we're going to look again at that little button. And I'm going to stop here and entertain any questions if there are any. No questions? I remind you to type your name in chat if you haven't already. So back in this little scene here where we had our button, where's our button? So here's our UI. Oh, I'm behind it. Here's our UI. And looking at the button, I've got its rect, and I can adjust its position. I can adjust its width and its height. And I can do this by typing numbers in the boxes here. But an easier way is to use the Rect tool. You remember we had the Q, W, ER, and I believe T triggers this one. And this is the Rect tool. And so now with this, I can move this thing around and put it wherever I want it in the scene. I can make it bigger. I can make it smaller. I can move it around and adjust it. And as I did that, all of these numbers over here changed, and we can also type them in there as well. Here comes the tricky part. Let's see, Rect. Anchors. Anchors are the tricky one. These little diamonds here in the center are the anchors. And we can grab these things and fiddle with them. Whoops. We can grab these things and fiddle with them. But it's hard to understand exactly what they're going to do. Here I've just randomly done something with these things. If I play this, I don't know what my button's going to look like. It's going to change size as I have different size windows. And that's because it's adjusting it relative to the position of these anchors. Now, the default setting there, and there's this little tool up here that gives you various preset defaults for the anchor position. This is all of the anchors in the middle. And all of the anchors in the middle means that this thing does not scale, and it maintains exactly the same relative to position to those anchors. So if I have different size screens, so for instance, if I now go to full screen, the button is kind of over in the center here near those anchors. I think I actually didn't reset the anchors properly. Let me reset the anchors to the center. Now when I play it, you'll see that the UI element stays relative to those to the center. It doesn't change size or shape, but its position is now down closer to the center. Now the presets that I kind of like and make life easier are if you put it in the corner. So any of these around the edge are going to put the anchors either in the corner, the middle, this corner, this middle. So as we go around this loop, it's going to put them in those corners. And now if I take this button, get the Rect transform, and I put this up, whoops, and I put this up, that's not what I want. I want the button, not the text. You notice the button has a text in it. If I put this up in the corner and I have my anchor in the corner, this whole thing is going to stay nicely in the corner even when I run this. And I've seen a number of you who are trying to do UIs for the various homeworks, and one of the issues is your UI works in full screen, but it doesn't work in the editor screen, and it might not work on a mobile device or some other thing. The anchors are what we use to enforce the shape and size of our UI elements. I will mention here, before I go on, that these other settings, these along here, are for stretching it. So if I pick this one, now my anchors are here and here, and that means this is going to be stretched to have the same relative spacing that it has on this screen and it will have on the big screen. So this is going to stretch my button out and make it wider as it stretches out to accommodate those anchors. So this is a TMO, lots and lots of options with the anchors. I recommend trying them out, TTO, the TMO. I find all four together, either at the center or at one of the corners or along the side, give predictable results. The item doesn't scale and its relative spacing remains the same. I'm almost out of time, but I'll show you a little trick here. So I'm going to add a UI element called a panel. And the panel initially fills the screen here, but I'm going to grab its UI and I'm going to drag it over here, and I'm going to drag it up here, and I'm going to set its anchor to be in the upper right corner. And I'm going to make a button a child of the panel. And the child of the panel, I've got a stretch on it, so that's okay. So now if I run this, my little button is going to stretch to fill the panel. It didn't stretch, but the panel is not going to change its position. And if I take the rect here and I move the, oh, I see what's wrong. The panel button should have stretched. Should have stretched. Well, I don't like the stretch. Let me turn that off. I'll put that there. So the button is now confined to be that relative spacing to its corner, and the panel is connected to that corner. But I'm going to change my mind and say I want to move the panel down to this corner, and notice that the button comes along with it. And I can now reset this to be in the lower left corner, set my anchors to be in the lower left corner. And so the button now stays where I wanted it to be in that frame. Stays where I wanted it to be. Now the other trick is a layout group. So this is a component that comes from the layout pull down, and I'll pick, there are three of them. There's horizontal, vertical, and grid. And I'll do a vertical layout group. And this now is going to automatically lay out the position of my button. And I'm going to specify that I want its width and height to lay out. And I'm going to say that I want 10 spacing left, right, top, and bottom around it. Now the nice thing here is if I make another button by duplicating it, it spaces those buttons out automatically within the panel, and I don't have to do a thing. It's all set for me. The spacing and alignment of these things are all done by this vertical layout group that I've put on the panel that contains the children that are inside it. And I can change the padding and spacing and so forth. And I can change my panel and the spacing of things adjusts when I do this. So all pretty cool. And of course the panel, if you don't want to see it, has a color And I can make the panel invisible here if I don't want to see the panel, or I can make it completely opaque if I want it to block out what's behind it. So lots of things that we can adjust here with our different buttons. And I'm out of time, so I'm going to stop sharing here and entertain any questions about UIs. And we'll come back on Wednesday and do sliders and texts and write scripts to manipulate these things and add them to our game for a UI. Questions? Well, I'm going to stop recording then.